you might ask, like, what is coding? And let's see, Valerie, can you wager a definition at what coding is?
Building computer language where you can transform some instructions to a thing that you can actually use.
Yeah, so some of the elements of the words that you used are certainly strongly relevant. You said computer language. So you need to communicate to the computer in a certain way. You said instructions, which means you're telling the computer what to do. It doesn't mean that it's the only thing it listens to, but you're giving it direction. And then you said something it has to be useful. Ideally, it has to be useful, and it's not trying to actively kill you like a robot from one of those new horror movies that received some instructions in a computer language, was told what to do, and then started to try to, kill their owner or something like that. So ideally, it has those qualities that it's useful, that it's something that you've instructed, and then you need some sort of language to express. So let's see, Ricardo, what's the name of a computer language?
Python, for example.
Okay, Python. Rafael, what's another computer language?
C++. plus plus.
Okay, how about Jonathan? What's the oldest computer language that you can think of?
I know there was something earlier than C. I forget what it was.
Yeah, so there's lots of things earlier than C. There's BASIC was earlier than C, and then Fortran was earlier than C, COBOL was earlier than C, and then before all of those, you also had assembly language, which can do things as granular as set zeros and ones in a digital memory individually. And then you also had punch cards where you would punch holes in a card and feed it into a computer, and it would tell the computer what to do. When I was younger, I used to think, oh, that stuff was primitive. This stuff is new. But in reality, all of these languages form a continuum over the last 70 years, starting with specifying the zeros and ones inside a computer. And not all computers are binary. We're now developing quantum computers that have more than two states. And just maintaining the state alone is like a huge production. But there are benefits in terms of the efficiency of a computer that might be built with more than just zeros and ones and with different physics so that some operations become much easier to do than the operations you can do in hardware. Some people have even written about computing with DNA. If you can express what you want to do in the A, T, C's, and G's, then and add some of these standard enzymes that interface with DNA, then you might be able to get it to solve a problem that, like Valerie said, is useful to you. So what the outlines of what Valerie said was really interesting because it didn't rely on a substrate for computing. It didn't say it has to be done on an Apple computer or a Windows computer, a Linux computer. It didn't even say it has to be done on a computer. It could be done in a beaker. And so people are also developing and programming cells to selectively identify cancer mutations and then to initiate apoptosis in cells where cancer mutations are manifest. And that field is called synthetic biology, programming cells. The concept of programming is broad. And then the final thing I would add is, Valerie, when we were talking about your definition of programming, we were saying, oh, we're going to tell the computer what to do. The latest thing that the computer can do is it can start to pull information from its environment and learn and improve itself. And in fact, the algorithms behind that are really just setting the substrate for a system that learns by itself and or it learns from data and from observations, sometimes labeled data, sometimes unlabeled data. And that's this deep learning stuff, neural networks, a whole bunch of them with billions of parameters and even trillions in the case of ChatGPT. And so, can you set up a system that programs itself? That's the kind of basis behind deep learning. And really, what's interesting is the power has been in the hands of programmers to create these things, these software systems that we use today. But now, as we go into radiology with these models, the programmers don't understand. They understand how individual parts of the system work and put together. They understand how to curate data at massive scale to feed it into these systems, and they have ad hoc methods to try to feed the system. But at least 70% of the data, let's say in radiology AI literature, is really about ideas that you guys can come up with, which is how do you train each other to learn radiology? And the intuitions behind, there's a thing called contrastive learning where you show examples that are strongly different or mildly different, and you might go from really different to less different exemplars as you start to prime the system into solving problems. There's a lot of intuition that you know when you're trying to teach, let's say, an underclassman radiology or learn it yourself, that now becomes relevant to teaching these systems efficiently. And there's still a massive problem there, which is these AI systems require 900,000 examples of a chest X-ray in order to put out like a mediocre report that still needs editing. And there have been some peer-reviewed large-scale studies out of Northwestern and elsewhere that showed really questionable productivity gains when you're forced to review the output of the AI before you sign off on it. So if you have like a few errors here and there, you just don't know where the errors are. It's actually ends up being slower if it's flagging, let's say, a pleural effusion or a pneumothorax. It becomes slower to then go back and read it and then go back to the imaging. You can imagine when your attending works with you, they develop a level of trust with you. So they go back and re-review and sign. But if they've worked with you and they know you're smart and reliable after spot checking you, they start to defer to your report and almost auto sign it to get through their day. And so I have seen attendings get through, let's say, 100 MRI, brain and spine and neck in one day, in less than 5 hours of work, because they had two fellows they trusted working with them. And we don't have that level of efficiency with AI pre-reading yet. And fundamentally, it's because the architecture and the way we're training are fundamentally flawed. There's something wrong about having to train a pre-trained network on 900,000 exemplars before you get only mediocre results. All right, so that's enough about coding. Let's do a recheck. Jonathan, how would you define coding to an underclassman?
I guess in the traditional sense, writing an explicit set of computer instructions to do, said task. But I'm trying to think of how it changes in the context of deep learning, where it doesn't have to be so explicit.
Yeah, so you could soften it up by just saying providing some instructions or telling a computer what you want to be done. We're talking about today, vibe coding. Raphael, do you know what language we're talking about using to program today?
Whatever the output of the AI system is.
No, you're coding in English. That's what's incredible about this. So if you know English or any other language, really, any other human language, you can start specifying for the computer what you want to get done. So let's go ahead and jump into that since Raphael's all settled in, set up. Um, so there's a concept of an um, developer environment and or an integrated developer environment. It's abbreviated IDE. It doesn't mean investigational device exemption. Integrated developer environment. But it's basically what it is. It's like you have a text editor next to some other tools that help you code, and that's what VS Code was. This is a Microsoft product, and for many years they charged for it. And then more recently, within the last few years, they turned it into an open source project. So anyone could use it for free, and the code was available so people could develop versions of it. So then a group of developers created a version of VS Code that they called Cursor. But if you download and use it, it will look like VS Code, all the layouts. They didn't bother to change the icons or the buttons or anything. They just plugged in ChatGPT, like Rafael was mentioning, so that it could see all the files you had open and then add to those files. And so it could do things like sentence completion. Like if I'm working on, let's say, my website for Orbit CME, which is a automated way to earn credit by whenever you visit Radiopedia or any radiology journals or PubMed, it'll automatically earn Category 1 credit for you. You guys don't need this because you're residents, but when you're an attending, earning CME is something that's a compliance requirement. Sometimes you have to earn it fast because you need to credential somewhere for your CT coronary studies or something, and they just need 50 credits in CTA of the heart. And where are you going to get that? This is a solution we solve. You earn credits by reading abstracts and articles on the web that are freely available to you. But sometimes I want to edit this site, and so it by editing it in Windsurf or Cursor, it already has all the 50 plus files that represent this website. And so when I type in, let's say, Category 1, it already knows I want to put the word credit and the TM symbol next to it because it's available. That's the, string I've used elsewhere on the site. Like you can see down here, it says AMA Category 1 credit. So because Windsurf and Cursor have the full context of all of the files that you're using, it's able to do sentence completion, and you can also give it or you can try to give it high-level directives and follow. The problem is that for a while, Windsurf and Cursor, it would generate code, and then you could run it locally, but that required more developer experience. And then on top of that, you would see bugs, and then you'd have to incorporate those bugs back into the environment and then have it edit. And so there wasn't a fully automated process of generating code and testing code. With Google Anti-Gravity, which just came out like 2 weeks ago, they've really solved it in such a way that I felt like it was easy to run a session like this. We're now 25 minutes in, we haven't even started coding, and yet we're going to have something close to a finished product by the end of this 60-minute session. And so what Anti-Gravity did that Cursor and Windsurf, it built on Cursor and Windsurf and VS Code. It literally is a version of VS Code. So Google copy pasted code from Microsoft to create anti-gravity. And if you had been using one of these tools, you'll recognize all the buttons on anti-gravity, or at least they took a subset of those buttons. But the other insane thing that they were able to do is connect the IDE, the integrated developer environment, the plus chats, the chat capability that was already here. They're able to connect it with a third thing, which is the browser. So with the Chrome browser, you now install an extension, which you guys will be doing, and the extension allows Google Anti-Gravity to talk to the Chrome browser. And now you can actually see the AI moving the cursor on the screen with the browser and making sure all the buttons are working before it reports back to you and says it's done. And it can even take screenshots of its own browser, of the browser, and say, oh, there's something wrong there, that didn't work, and fix it. Now, it's not at 100% yet, but that's just today. Imagine like a year from now, you won't even have to tell it, hey, that didn't work. That's what I do. You'll see we'll have to do that once or twice and say, try again. And it'll go back and fix whatever you don't like. But you can imagine in a year from now, you're not going to have to do something as silly and easy as that. It's going to be even more about probably 6 months from now or 3 months from now. So that's Google Anti-Gravity. It lets you really be mission control. You're not specifying every movement that needs to happen out in the field. It gives you that Chrome browser that's controllable by the AI. So when you think about vibe coding, these are the steps of vibe coding. The first is you tell the computer in English, like what you're trying to build, what you want to build, and so that's the prompting part of it. Exactly like you're using ChatGPT, and then vibe coding is acting as a consultant for you. So in the review process, sometimes it'll just jump in and start doing something, but sometimes it'll come up with a really detailed plan in a text file that you can go ahead and edit. Like, you know what? I think you got the equation for creatinine clearance incorrect here, or this isn't the latest paper that I wanted you to base this calculator on. I want you to base it on this other thing. So it gives you a chance to intervene before it jumps in, burns a lot of tokens, creates a lot of greenhouse emissions, and creates code that you didn't need. And then finally is the test phase, which is where it goes ahead and moves the cursor on the screen, makes sure all the buttons are working for you. You can also you can ask it to test things. So you can say, listen, I don't want to click through this calculator. Let's say it calculates, we're going to do like a trauma score. I want you to go ahead and go through all the possible combinations for anything that a resident would have to use this calculator for and show me that it's coming with the correct recommendation. And then output all those testing combinations in a CSV file for me to manually look at. So in the concept of vibe coding involves these three elemental steps, and perhaps from your perspective, because you're not actually granularly specifying the code, from your perspective, the prompt on what you tell it to do, that's important. And one of the rate limiting tests for you is the testing, seeing the output and deciding whether it was good or not. And now, if you're creating something like a web page for a personal website, or you're creating a calculator for someone else to use in your residency program that you want to embed into a wiki site that's internal to your program or for something, the buttons, the color of the buttons, the shapes, the branding, that's something you can very quickly perceive as right or wrong with your eyes. And so the testing part is very quick. But let's say you want to validate the calculator itself. Is it outputting the correct recommendation? For that, the validation is slower, but you can ask the AI to code. Usually it will code in Python or JavaScript, and it will actually use the same code and run it through its paces. So I've done it for a calculator where I had to test like 200 different diagnoses and conditions. Instead of me manually doing that, I said, okay, can you just do this for me? And then I wanted to validate its output, so I had to dump it into a spreadsheet. So there are ways of testing that are slow and ways of testing that are fast. When we think about radiology AI, um, the testing involves seeing if let's say you're trying to go from DICOM image to a final report. Raphael, what is the testing in that process? Let's say you're vibe coding a solution for that. What's the testing phase there?
I guess you could manually go through every scan and see if it's accurate.
Okay, great.
Maybe you could feed the scans similarly to to an AI and ask it what it thinks of the scans to see if it can correlate with the results.
Oh, cool. So yeah, you can do training between two different AI agents. Sometimes if you're trying to harden a system, let's say you're trying to get the corner cases of epidural hematomas that are really or extraaxial hematomas that are really subtle, for example, you can harden the system by having one AI system generate really hard cases for the other and then grade it on its output. So you can definitely do auto grading in that regard. One of the cheapest ways to do it is you already have a database of hundreds of thousands of scans going back 10 years. Radiologists have already read those. It took them years to read that, and now that is available as the output answer to grade against. And then the grading itself, what your AI output as a report versus what the radiologist report was, that can be done with an LLM. So testing can be expensive, or if it really needs manual human intervention, like Rafael suggested, would you have to grade the output? Or it can be really cheap. I think fundamentally in radiology, the testing is expensive. It's just that it's already been paid for. And that's through the blood, sweat, and tears of all the radiologists that read the studies over the last decade. And same thing in pathology when they're doing pathology AI. Um, the last piece of vibe coding is that you need to have an undo function. So the way this works is, if does anyone here rock climb? When you rock climb, there's top rope and there's lead climbing. So top rope is what you get in most of the gyms, and someone's pulling on your rope and keeping you up. But in lead climbing, you have to put down. Maybe you're on a rock face that doesn't have any anchors on it, so you have to tap in an anchor. You have to tap in this little anchor, and the thing about tapping the anchor is you're essentially saving your spot on the mountain, and then you try to reach for the next point. But if you fall, if that next point doesn't work out really well because you've chosen a bad anchor, you've chosen a bad path, then you fall back to where you tapped in to the mountain earlier. And so you want to be able to do that with vibe coding, because what is vibe coding? It's basically, you're not even looking at the code generated by the AI. You're just looking at the output and seeing if you're happy with it. But what if you're not happy with it you're doing it in an iterative process. So you've done work for an hour, you're super happy with the output so far, but you want to change the logo to your institution logo. So you say, okay, go ahead and change the logo. And it says, okay, I'll do that. And then it completely messes up the rest of your code, or messes up some of your code that you don't know what messed up, but it's no longer loading. How do you hit Control Z and come back to that previous state? Right now, it's not exactly built in. They probably should make it a little easier, but what you have to do is connect your vibe coder to some repository, and the one that everyone's using is called GitHub. And what it does is it uploads, you can actually locally save the last version that you're happy with. It's called a commit, COMMIT. And there's a graphical button that you can click in these IDEs to commit. And then let's say you do another round with the vibe coding and then it goes somewhere you don't like, then you can discard those changes and come back to your last commit. So that's the sum and total of vibe coding. It's kind of like rolling the dice, seeing if you like the output, and if you don't, reverting back. And if you do like the output, you keep it, and then you roll the dice again and make another request.